And we're live.
Okay, doke. Welcome. Welcome from Berlin, Marco Heimershoff today. And with me are my colleagues Kenny Bas Swechler from Amsterdam and Christina from, I don't know where in Germany you are actually. But
I'm in
welcome to
Cologne.
Cologne. Yeah, thanks. So welcome to another session of Virtual Domain-Driven Design. Today with us out of London is Hibri Marzouk, a cloud architect, way too humble to call himself a system thinker. And he's talking about counterintuitive ideas in software development, how, for example, more slack time gets your teams to be more reliable. I'll hand it off in a second, but for everyone else joining us on YouTube Live or on Zoom, please write your questions in the chat and we will answer them after the presentation. So I would hand it off to Hibri. Welcome, Hibri.
Yeah, thank you, Marco. Shall I share my screen now?
Yes, go ahead.
Yeah. Cool. Cool. Can everyone see my screen?
Yes.
Yeah, let's just make sure slides on here. Cool. Hey everyone, good to be here and doing this virtually. It's very comforting, and lots good to see lots of familiar faces from Amsterdam earlier this year. Today I'm going to be talking about how we can get better at understanding counterintuitive ideas, things that don't make sense at first. And I'm going to pick software delivery as a domain. I'm going to talk about counterintuitive ideas in. A little bit about me. My name is Hibri. I'm a principal engineer at ClearBank, where I work in the platform and infrastructure space. I help build platforms so that devs can deliver what they've built to their customers quicker. So having said that, let's get started. So why am I here talking about this? Software delivery is complex. We've got so many conferences on how to improve software delivery. If it was easy, there wouldn't be much to talk about. We'll just copy one file from one computer to another, and that will be it, right? And it's complex enough, to justify, whole tracks at many conferences. Like if you look at the conference ecosystem, there's so many conferences that are dedicated to software delivery. It's hard because, more than just copying files from one place to another, we have to make decisions. The software delivery process is a process of, making decisions at many points. And in addition to making those decisions as humans, we also need to trust the tools and the technology that it does the right thing, because in a mission critical system, if your software delivery system doesn't work well, you could end up making huge mistakes, people's money disappearing, could affect health systems and so on. And there's a lot of moving parts to make this work, right? It's mind-blowing. And if I look at the landscape of tools that even a simple software delivery system has, it's just absolutely mind-blowing. All of this increases our mental cognitive load. These systems we build are complex. They're complex socio-technical system. It's just not tools. What makes it complex is the social system that it's built in. If it was just a tooling problem, we would have solved it long time ago with Jenkins, right? But now no one talks about Jenkins, but the problem is still not solved. Conway's law has an impact on our SDLC. How we organize ourselves socially influences how these systems work, right? If you have silos in your organization, that will get reflected in your software delivery life cycle. You'll have friction. And a dev team needs to get to grips with all of this complexity. It's not easy. And adding to all the technological and sort of social complexity, we got all the emotional complexity. I showed this, soup of technologies that we have to implement. This leads to imposter syndrome. So these people sitting here trying to get the software that they've built into the hands of their users, they've got imposter syndrome, feeling of helplessness, like can't figure out how NPM works, depending on the phase of the moon. It could be broken. They'd be frantically googling things. Fear of control. They are, who makes the decisions. Fear of change. It's like, why are we changing things? What, for example, Jenkins worked. Why are we changing into something new? And most importantly, especially in a siloed system, there's this depletion of emotional energy, having to talk to different teams. Hey, I just want to get some stuff out, but talk to your ops team, talk to your QA people, and so on, right? And yeah, navigating all this organizational silos depletes our emotional energy. And to get better at this, you have to read the whole Accelerate book, which is a great book. It does a brilliant job of identifying all the complex stuff that needs to work, so that we can deliver fast, right? But all of us sort of started coding with HTML. Hey, look, I can build something cool. It was fun, but then when we started our professional lives, like we're put into all of this complicated mess. So we want to build cool stuff. So this got me thinking, what like the nature of the problem. In 1973, Rittel and Weber coined the phrases wicked problems and tame problems. Wicked problems are ill-defined, ambitious. They're associated with strong moral, political, and professional issues. They're strongly stakeholder dependent. There's very little consensus about what the problem is, like let alone how to resolve it. And wicked problems don't keep still. If you solve one wicked problem, uh, it gives birth to 5 more wicked problems. And wicked problems tend to be a symptom of a problem somewhere else. So how is software delivery a wicked problem? So if you look in within your organization, everyone has a strong view on how your delivery lifecycle should work. The testers would say one thing, the ops people would say one thing, the devs think, yeah, I've just written the code, it's not my problem. Getting it out is someone else's problem. The testers would say, like, why are the devs sending us buggy stuff? It's not our problem to raise all these issues. And even if you work in a company that buys into XP, TDD, all the agile practices, any 2 individuals will have strong views on different things, and how things are implemented. And that's fine. And you can't see wicked problems in like good or bad terms. It's not binary. What's good enough test coverage? Like 100% or 30%? It depends. And there are no one-off solutions. And the problem isn't going to be solved when we magically say, you know what, let's put in Kubernetes. It'll fix all our problems. It just creates more problems. The hard part with wicked problems is that if you think you have a solution that worked in another context and you try to apply it in your current context, it won't work. So there are no defined solutions for wicked problems. And your software delivery lifecycle might not work great because your HR department has not set the salary bands so that you can get skilled people in. So that's an example of your wicked problem being a symptom of a problem elsewhere. So how do we solve wicked problems and how find solutions? This, it involves changing people's behavior. It involves breaking down organizational silos. That means changing the relationships between individuals and change the relationships between teams. For example, relationships collaborative. In a small startup, people will just talk to each other and get stuff done. But as things grow, sometimes they end up being antagonistic. Teams really get into the siloed mindset, and then they talk with tickets. Solving this problem means that you have to see things from different perspectives. Your ops people have different perspectives. Your testers have different perspectives. Your devs have different perspectives, and these are all valid. Sometimes, no one is wrong. As I said, you can't see this in binary terms. So to improve things, we need to see the whole system and see everyone else's perspectives. And we know what the solutions are to the wicked problems in software delivery. We wrap them in these counterintuitive ideas, these mantras that we repeat. If it hurts, do it often. Taking more slack time improves your flow. People learn and the system improves. And releasing more often improves quality. A lot of us who got enough experience in this industry understand these ideas intuitively. We sort of know how it all works, right? But if you try to explain these to a non-technical stakeholder or someone new to the industry, we haven't done a very good job of that. We tend to rely on, let people learn it through experience. So what we're going to do today is to pick one of these counterintuitive ideas and see how it works using systems thinking. So I was listening to the podcast. Nicole Forsgren who wrote the Accelerate book was on it, and at the end she was asked, what's the simplest thing we can do to improve software quality? She said, deploy more frequently. If I say this to a CEO or someone non-technical, they would ask, why would we deploy something we know that could have bugs? Why would you do it more frequently? Shouldn't we take our time until the universe ends to test and test and test and make sure everything has zero bugs? How does it make it better if you know it has bugs and you deploy it faster, more frequently? How does that work? So we need to get better at explaining these counterintuitive ideas. And in software delivery, we always talk about feedback loops, but how often do we step back and actually see these feedback loops? How often do we model them? What I've seen is that anecdotally, we are good at modeling what we build, nice user story maps, event storming of what we're building, but we aren't good at modeling how we work to build the thing. So we need to get better at modeling how we work as well. And if I try to explain software delivery, I end up looking like this, end up looking like a crazy person going across the whiteboard. So from this today's talk, if you take one thing, is about how to model and see the software delivery system you're working with. I pick software delivery, but these techniques apply to any complex system as well. So it's important with modeling to tell a story, right? So let's get started. We're going to tell the story with causal loop diagrams. I'm going to tell a story from my perspective, and I'll build a very generic model. Your system will be different. So before any talk of models, obligatory quote, all models are wrong. Some models are useful. Why are we using causal loop diagrams? So like I said, software delivery is full of feedback loops. Causal loop diagrams are one of the best ways to visualize them. They're made with three basic elements. Boxes, here, what you see, A and B, those are your boxes, and connection lines. So here A is connected to B. That's a relationship between A and B. Here we talk about the nature of the relationship. That here, because of the polarity, the plus sign, and the direction of the arrow, A influences B. Here, an increase in A increases B. It can be an inverse relationship too. A reduction in A increases B. These diagrams are one of the easier ways to start thinking about systems and get into systems thinking. But they are not the only way. You can choose different mapping techniques, Wordley maps, rich pictures, different modeling techniques, and they're all valid. And each mapping and modeling technique gives a different perspective. And sometimes it's important to use, one or more modeling techniques to see different perspectives. So here we want to visualize feedback loops. So let's get started. We first start with a variable, which is relevant to the question we want to answer. Since we're talking about software delivery, we talk about a release. Here I'm picking the size of a release. So if you take a release, it has a number of changes. Some of these changes will break in production. Some of these changes will work in production. We don't know until we actually release it. And we won't know until someone actually uses software in production. So we take that variable and see what contributes to it and what it contributes to. So the size of a release contributes to the number of failed changes in a release. Another way of looking at it is like a release is like getting a box of chocolates with mixed flavors. Until you eat them, you won't know which ones you like. So the bigger the chocolate box, the more likely that there will be failed changes. So the probability of failed changes is proportional to the size of a release. All we try to do in our software delivery is try to reduce the probability of failed changes, or the chocolates we don't like. So let's get back to our model. When something fails in a release, it causes quality issues, and obviously, these need to be fixed. And this is reflected in the change failure rate. So what we've done is like establish a relationship between the size of a release, the failed changes in a release, and the change failure rate. So this is a simple relationship. So we are not done yet. So when things break, what happens? We need to go fix things, and to fix things, the resource that we need is time. Time to fix the broken changes, either by rolling forward or doing a rollback, testing the roll forward or the rollback. And this time is toil. In lean terms, it's waste. It's time not spent on building things that add value. So obviously, the less time we spend fixing a broken release, the better. Unfortunately, there's no magic technology that would just fix a broken release instantly. So us humans have to intervene and spend time and figure things out. While we are fixing a broken release, we are adding a delay to a future release. Why do I say that? In many organizations, like while a release is being fixed, devs are still typing. They don't stop work, because everyone needs to be busy. So devs are still adding changes. This the double line in the causal loop diagram indicates like a delayed response that can, and it's not an immediate response, a response that comes in a week, a month, or even like years years later. So while devs are adding new changes, what happens? The size of a future release gets bigger because they haven't stopped typing, right? So now we've closed our loop. So what happens when a release gets bigger? That's it. Chocolates I don't like. So the longer we spend fixing a release, the bigger the next release gets. So by using a causal loop model, we've now established a relationship between the current release and the next release. And now you can see, this is how our system works. This is the engine that's driving the socio-technical system of our SDLC. Because we've modeled it, we can identify patterns. One of these patterns, marked as R1, is a vicious cycle. It's called R because it's a reinforcing loop. In a reinforcing loop, one variable reinforces or increases the impact of the next, right? So if you see here, there's plus signs all over. So increasing the size of a release increases the probability of failed changes in a release. That increases the change failure rate. That needs more time to restore a service if things break. While we are doing that, the devs are still typing, and we've increased the delay to the next release. That increases the number of new changes, and that increases the size of a future release. Right. So the circle, we are in a vicious cycle. Not all reinforcing loops are bad. It depends on the context. This model also shows us the things we can control and the things that are a result of what we do. For example, we can't control this change failure rate because that's influenced by the size of a release. We can't control the time to restore service. We can put an arbitrary limit, like must restore service in 5 minutes, but it doesn't always work. So what we've done here is we've observed our system as is. We haven't made any changes yet. And it's important to test our model with actual data, observing people work, and look at a few recent releases to see what's happening. So we have a reinforcing loop. Obviously, if this was a real organization, things would keep getting worse and worse, and the size of release would just explode. But that doesn't happen because people intervene in the system. So let's model the impact of some of those interventions that we see in our industry. So to intervene, we need to reduce the influence of one of these variables on the next. So as soon as we start reducing one of these, the next thing reduces, and the next thing, and the next thing, and the things system starts getting better, and it doesn't become a vicious cycle anymore. So most obvious intervention. Let's take more time to test a release, right? Let's model that and see what happens. So we got our army of testers. We got a manual regression test. Let's see what happens. So taking more time to test a release, what happens? Sorry, let me go to the previous slide. Yeah, so we take more time to test a release, and that's valid. Taking more time to test a release can reduce the probability of failed changes in a release, and that's fine. But let's see what happens when you take more time to test a release. The more time we take to test a release, we're just increasing the delay to the next release. So even though temporarily we've fixed the problem, we haven't changed the system. The longer the delay to the next release is, the devs are still typing, right? So you see where the cultural problem also comes into play. So let me say that in a different way. If we have a culture of continuous flow where there's collective ownership and there's a stop the line culture, the devs won't be typing while you're fixing a current broken release. But if you have a siloed culture where you have, like, the devs do their job, the testers do their job, and the ops people do their job, you'll see this behavior. So taking more time to test a release is a band-aid, hasn't fixed the problem. Let's see another common intervention. Every December, release freezes, yay. You get Christmas parties and release freezes. So let's model the impact of a release freeze. So what happens if we have a month-long release freeze? It again increases the delay to the next release. The devs are still typing, adding new changes to the next release. So release freezes work only if you send the devs on holiday, take time off to learn, hands-off keyboards, and yeah, it only works, if there's a code freeze. But that's a cultural problem to solve. So by modeling different interventions, we can see what the impact is. What about other things that add to delays between releases? So we can start asking questions of our model. For example, manual deployments, they add a delay to the next release. The longer you take to do a manual deployment, the more time you take, and that increases the delay to the next release. And then the worst part of manual deployments is that it increases toil and errors into the deployment process, which means manual deployments like forces people to get stuck in over here. They fix things, break things, and then that takes more time. What if you have end-to-end regression tests? End-to-end tests take time, they're fragile. Before release can go out, you need to look at the reasons for fragility. I've never seen a place where they have end-to-end tests and they've got the tests all green so that they could release. Everyone goes is like, how red or orange are our end-to-end tests, and sort of make a judgment call on that. So we've seen some common interventions. They don't create lasting change. They don't change the system. It actually makes things worse. So how do we make lasting change? Let's look at an iceberg. So in systems thinking book, Donella Meadows describes where to find leverage using an iceberg model. So we can use this to find leverage to make lasting change. An iceberg has more below the waterline than what we see. And what's below the waterline is what shapes what we see. Modeling a system with the systems thinking and causal loop diagrams allows us to see what's going on below the waterline. So let's apply this to what we've modeled and start. So at the top, above the waterline, we have events. Events tell us what just happened. We can use our model, walk through a recent release, and see all the events. Like, we did a release, some failed changes in a release. It took time to restore service. So these are like discrete events. What's the reality? So again, the model you draw will be different. The events in your system will be different. It's always important to make sure that your model tells a real story, and you should be able to have a conversation with it. So events are the visible part of patterns of behavior. When you add a time element to events and start to connect one event to another, we see, how one event causes something else, how they interact, what has been happening. Has this happened before? You might even see these patterns of behavior in your data, like, after every release, you might see the bug count going up, and then people start fixing it, and then it goes down again, and then the next release goes up again. So like sort of keep going up and down. Patterns of behavior are influenced by the structure of the system. What's the nature of the relationship between one event to another? Why is one event connected to the other? So in our model, we have mapped the nature of the system, and what is shaping the behavior and causing to patterns to appear over time. So now we've modeled the relationship between issues in the current release and a future release. So the structure of the system is influenced by the mental models of the people in the system, and modeling makes it visible. The system doesn't sort of exist on its own, because we're talking about socio-technical systems. All of these events are how we interpret these events, how we react to one event and what we do. All this stuff is it's in our head. For example, we see that the mental model of optimizing to keep devs busy causes quality to suffer. So that's a mental model. We see that if there's a mental model of a team owning the end-to-end delivery, that things get better. So it's still the same system, and how things are connected to the same, but we can see the behavior of the mental models that people in the system hold, and how it gives different dynamics. So we can start asking questions again. Okay, what if we had work in progress limits? That puts a limiting factor on the number of new changes that go into a release. So it doesn't start to make things worse. That vicious cycle has a limiting factor. We can ask, do we have the right tools to do automation? Is there something inhibiting learning that's holding us back so that we can invest in automated deployments? Do we have enough slack time to learn? So we can start modeling those things. We can also see, the impact of another counterintuitive idea, start finishing, stop starting things. So we now have a better understanding of why increasing deployment frequency improves quality. So increasing deployment frequency reduces a delay to the next release, and you can see things like automated deployment increase your deployment frequency. Having the right tools, having manual deployments reduces your deployment frequency. So increasing your deployment frequency reduces the delay to the next release. So to make the system better, this is the variable that we have to have an impact on. And intervening in that's our leverage point. Intervening elsewhere doesn't make doesn't give a lasting change. So that reduces the delay between releases, which reduces the batch size, which in turn reduces the probability of failed changes in the release, and then that reduces the amount of time spent on toil, which is fixing issues in a broken release. So I've done this by myself, and it's completely fine to build these models for your own understanding to help you coexist in a complex system. But it's even more powerful when we build the model collaboratively. I show this to someone, if I show this to some of my colleagues, they can challenge their own mental models or help me challenge my own mental models. So this allows me to see different perspectives. And this gives us more leverage in the system, because now what gives us more leverage in the system is going towards the bottom of the iceberg. So all these counterintuitive ideas that we repeat as heuristics, mantras, and we keep telling people this is what you should do, these shape our mental models, and it's our mental models that influence us reacting to events. And even personally, it helps me understand how I react to certain things. And and we can see what mental models are behind the patterns of behavior and events in our current system. Like releasing once a month keeps us safe. So people have that mental model that gives rise to a different set of dynamics. Having devs and testers in different teams, like hero culture. Yeah, we rely on only the senior developer to go off and fix things, while all the junior devs are still typing new features. I've seen organizations where there are incentives to keep devs busy all the time. If they didn't finish stories every sprint, it was reflected in their end of year bonuses. So those incentives have an impact on our system. So solutions to wicked problems don't neatly fit in a Gantt chart. You can't have a roadmap. You can't have like a 3-month plan. It doesn't fit in PowerPoint slides, even though I'm showing it very linearly. Finding the leverage points and modeling our system helps us deal with the inherent complexity. And our software delivery system is not isolated. It always exists in a wider context. What's the organizational culture like? How does HR work? Is there psychological safety in the organization so that you can talk to people freely and collaborate? All of that has an impact on our system. And we can expand all these boundaries, but up to a certain point. I can't bring what happens in my personal life, what's happening at home, into this system. So we need to make boundary judgments to keep things focused. So when we started on this modeling journey, you see that we accept the system as is, and we just model what's going on right now before jumping in to intervene. So it allows us to observe, ask questions, and system exists because it works. We all of us here work with organizations that, based on our understanding, should be dysfunctional. They should collapse. But if you look at large enterprises, they survive. So before we blindly go and intervene, it's important to understand why things work and find the real leverage points. And the strategies to deal with wicked problems isn't static. You will make changes that will change things, and we have to understand the dynamics of a complex system. So just collaborative modeling, iterating on our models itself is a better strategy, which allows us to challenge our mental models. And yeah, to start to close off, like this quote from Diana's recent book, models are conversations. There's no right way. It's all about framing questions, exploring answers, and making sure you have a vibrant and healthy modeling process is far more important than which mapping or modeling tool you use. So Donella Meadows also says, dance with the system. Many of us here are consultants. We think, we can pull puppet strings and change things to make them better. But having dynamic structure means that, we can learn how to coexist with a complex system. And yeah, to end, I'll leave you with this quote. Has anyone heard of Dirk Gently? Yep. He thinks he can solve murder mysteries by figuring out what his cat ate for breakfast. He believes in the fundamental interconnectedness of all things. Yeah, so thanks for listening to me. Yeah, before questions, a couple of books that are kind of useful for me have been useful for me in my own learning journey. That I've used. If you're in the UK, the Open University has a free 8-week systems thinking course, which I found very useful. Covers a lot of modeling techniques and different ways of thinking. So thank you again. And any questions? I'll leave the model up here so you can ask questions.
Thank you so much. I'm going to start with a question from the Zoom chat. Marie Brunette Cortot, hope I didn't butcher that name, is asking, are you advising against using release freezes to address part of the refactoring backlog?
I'm not advising against release freezes. This is not about like me suggesting something. Depending on your system, you should see the impact of what the release freeze does, instead of seeing it as a solution. Like release freezes have an impact. You can have a release freeze, but if you keep on adding new features, your feature release just gets bigger. So you've fixed the problem for December, but you probably ended up making the problem worse for January and February. It's fine to have those in a dynamic model. What you can do is you can see, okay, let's have a release freeze. Let's see what happens. You can run experiments.
Yeah. Okay, thank you. And then Hans raised his hand. Hans, please go ahead.
Hello, can you hear me?
Hello, Hans.
Yeah, I can.
Okay, very good. I'm on my phone, so I hope it won't be too bad quality. So we've been talking about how increasing, making more deployments, production releases more often will increase quality, or is the fastest way to increase quality. But I would like to argue here that increasing the frequency of deployments does require some sort of base level of technical quality, at least. For example, like backwards compatible commits and feature flags and hidden releases and all that stuff. So you don't break the production environment like absolutely every day. Or
yeah. So what I mean, but production breaks sometimes, right? And we do fix it quickly. if we get in the habit of, like what this model says is that if you have a smaller batch size, by reducing the batch size, you'll spend less time fixing production. So you're reducing the probability of things that could break. If you have a smaller batch size, some of those releases will be bug free, and you'll be releasing those quite frequently. Once in a while, less frequently, you'll have a release that breaks. But because you reduce the batch size, it allows you to narrow down the change that broke production. So you can fix things quicker. So this is kind of what the model says about releasing faster. It's just not about releasing faster. Releasing faster allows you to reduce the batch size of your releases.
All right.
So that's a counterintuitive idea. That's why kind of you use the model to sort of understand something that doesn't make sense. It's not obvious at first.
All right. Can I also ask a second question?
Yeah.
Is that allowed?
Yeah, sure.
So if you're already in this position where you have big releases, let's say monthly or something like that,
yeah,
and your product owner or your client knows that every release is big and scary.
Yeah.
How do we start to change that? I mean, if I would to bring this feedback loop diagram to him, he would say that just that's just developers talking the technical talk, and that would, for me, that would mean more things breaking more frequently, and that would maybe like hurt my reputation.
Yeah.
How do you change that?
So again, like you have to model this in your context. Like I said at the start, like how it is. But please don't take this model and say, like, like the Spotify model, like don't go like, oh, Hibri's software delivery lifecycle model, go and apply it. Like draw what's happening, model what's happening in your system, in your context, using causal loop diagrams, and see what your system is like. I can't give you the answer based on what you said. The Accelerate book does a really good job of like bringing all the different concepts together, but model what's happening in your system. Like how does your client react? How do your testers react? How do your devs react? It's important to see like what's happening in your context, and then you'll find the leverage point that works for you.
All right. Thank you very much.
Yeah.
Awesome.
Thanks for the questions.
Kenny, do you have anything on the YouTube chat?
Nope, nothing so far. I just asked again, so.
Then we have a story share from Javiera, working in a big tech company that did a code freeze for over a year to fix some technical debt, and that failed big time. So Javiera, you want to share that story?
Yeah, sure. So
Yeah, please do.
thank you. So this was a huge company that acquired another big company in South America, a big e-commerce. What happened was they needed to leverage their systems, and they're finding a lot of problems while doing that. So like the high-level CIOs, CTOs, they decide to do a full code freeze, they call like code yellow, in order to just leverage the technical dev with the new company, with their standards and everything. This felt like very bad because they start also hiring a lot of new devs. They needed to onboard these people. They say, okay, now we are agile, so no more meetings. That was like the first step. So they were doing this huge big bang, like no freezing everything, and it failed because at the end of that year they didn't have any new features, they have a lot of bugs, the integration didn't work. So
Yeah.
after that they moved a new strategy that it was like, okay, let's allocate the technical dev in a 40%, and then we will use team topology strategy. They create a lot of enabler teams to make sure that the teams follow this like sensible defaults that they needed to
Yeah.
migrate into. And then the 60% was to overcome like the new features. That approach was much more realistic.
Yeah.
And they achieved most of the teams after 2 years periods, but it was like now much better experience.
Yeah. What I forgot to say is that especially when leadership changes and organization strategy changes, like people say, you know what, no, let's not build a culture of continuous flow, let's silo teams. We can say, like, you know what, okay, that's fine, but let's see the impact of that in our model. Taking your example, like if we add a lot of new developers who are inexperienced, what does that contribute to? So we can say, like, you know, model kill, hey, a number of inexperienced developers, they are increasing the number of failed changes in the release. So we can see, like, okay, where the problems are, what are the proposed changes? Are they actually going to make things worse or better? And if not, you know, it ends up being like a what I said versus what you said argument. Yeah, thanks for that question.
Hey, thank you so much. So on my end, there are no further questions in the chat, and if no one else has a question and raises their hand. Christina, go ahead.
You wanted to leave, isn't it?
No.
I don't have a question. I liked it a lot. I have a completion or an additional sentence for Hans, because I think, you know, this picture is missing the big picture. If you accelerate, if you reduce the release time, people get problems much more often. So they will start fixing them instead of saying once in 6 months, oh, we wanted to fix this manual process, but it's happening only once in 6 months, so why should we invest? If it feels on your feet every day and you must fix it, we are engineers, we will fix it because it hurts. If it is not, because it's an exception, then it won't be fixed. Why should we? So this is the crazy part of continuous delivery, trunk-based development. Removing these artificial safeguards, or some other teams should fix it. But really setting ourselves in this position of, I broke it, I must fix it, and I do this every day. That's the biggest enabling of everything. This is what is missing maybe on your chart, simply adding constraints, enabling constraints. So removing excuses, removing this, I'm going on holiday. Things like this.
Would you say things like modeling the impact of this enabling constraint, like, you know, adding a whip limit?
Exactly, that's one. That's a very good enabling constraint, whip limit, because you feel that it's reduce your freedom, but it actually gives you freedom focusing on one thing.
I would like to add, there is a psychological feedback loop as well. I mean, as Christina said, when you do it more often, right, you get better at it and so on. There's also the psychological effect of it becomes not only a habit, it becomes an integral part of your actual work to have this mindset of, hey, where are any problems that I could solve? It's not the exception that you have to deal with every half year. It is, if you haven't solved a problem, it feels almost weird. So it becomes just an integral part of your identity as a developer. And that has an increasing effect on the quality as well.
One of the things, so causal loop diagrams, even though sort of presenting it here, like it's used in other industries, especially, you know, things like, you know, healthcare. Just trying to find one that I've seen recently.
We had a session 2 weeks ago. Lorraine is here as well, who showed a few examples as well. Lorraine.
Yeah.
So
if you look Google COVID causal loop diagram, it we can't get it. Yeah, let's see.
You must share it now because my mind went on.
Yeah,
COVID causal loop diagram. What can that be?
yeah, it's share different screen. Stop sharing. Let's try sharing again. Oh, I'm not sharing my screen. Here I want to go with sorry, I can't share my Safari.
You can share the link.
Or the entire screen.
Yeah, I think it's somewhere in this article. There you go. Yeah, share in the chat. So that maps out like what's the core driver of infection and how government policy and how trust in government policy influences people's behavior. Yeah. Yeah, so this is kind of all causal loop diagrams are not sort of not new. Lots of examples in other contexts. Cool. Thanks, everyone. Thanks for the good questions. Oh, thanks, Christina.
Share for
Yes.
YouTube. Great. I hope all the minds are going and thinking. We know about Marco, yeah.
So, I didn't want to jump in. Thanks very much. I think the people who are arguing about whether we should be rewriting or doing more releases, I don't think you're ever trying to give us an answer. I think, we just need to really keep in mind that it's about modeling. And rather than doing these random things like let's code freeze for a year, model it out and try and work out what might happen. So, we don't really want to get sucked into the continuous refactoring arguments, although I'm also on that side. But that's not the point, really. I think it's just so nice to see you working through those causal loop diagrams. And I don't know, Hibri, if you've played around at all with the stock and flow diagrams, because I just like them a little bit more because you actually try and quantify your flows. Very similar, but you think a little bit about the remaining stock and value and quantify it.
In my learning journey, I tried to make sense of Stockton flow diagrams at first, but then learning causal loop diagrams, and then, oh, okay, now I can see how Stockton flow diagrams could work. This is why I chose this. It's sort of like, okay, it's a bit of simpler way for people to figure it. But this is sort of like in the sort of low to mid level of people. It's like understanding of synthesis systems thinking. I think there's more rigor in stocks and flow diagrams, and then you can this complex modeling software that you can use. Yeah.
Thank you.
So going on that thing, I was once talking last time you talked about the archetypes, right, Lorraine? So the whole discussion about tech depth versus, because it's a two-way streak, right? If you focus on tech depth, you stop focusing on features, and usually then that ends up in what I usually see as a policy resistance, right? Similar to war on drugs, it keeps adding and it keeps being in that causal loop. If you really model it out, you most of the time see that part. That's why, yeah, modeling it out is very important to see if you keep pulling in that direction, right?
Yeah, it's a dynamic strategy, and it's okay to do some of those things for a little while. It's all about balancing. It's not like some of these we try to make these binary choices, but it's not like that. No, I've learned that the hard way. Like I can't go in and say like, all right, everyone stop what you're doing and let's do TDD. Doesn't work.
I mean, it's as long as you understand the why behind everything, it's a conscious choice, and you understand the trade-off, at least to the degree that you've modeled.
Yeah.
Then every decision is a fine decision. The problem is that most people don't do the modeling upfront, and they don't understand the trade-offs. They go by impulse, they go by whatever technology they fancy, and not understanding the why behind their choices.
And the policy resistance that Kenny mentioned kicks in real fast. It goes, I'm not going to do it just because you told me so.
Yeah, it's counter. That's what I usually see, right? The PO versus the engineers. Like each have their own goal. One is to build features, and the other one is to, well, make proper code that is easy to work in. Let's say that. Yeah, so it kicks in very fast. It's once you see it. Yeah. Nice. Yeah.
Maybe it's time to say goodbye.
Yeah.
Yeah.
It's because people are starting to evoke fist fights. Well,
Yes.
See, this is someone should model what's that law before someone quotes something on a forum. Yeah, I should model that as a causal loop diagram. How do things generate into a fist fight?
I know how, but we can't say it now because we are online.
Yeah. Shall we wrap it up?
Yes.
Yeah, the show. Thanks,
Sure.
everyone. Good to see you all again. Thanks, Kenny. Bye. Thanks, Christina.
Thank
Good
you.
to see you, Marco. Bye.
Before we go, one more announcement. In November, we're organizing a global domain-driven design day, which will be a virtual open space, and hopefully a lot of local meetup will join us that day, so people can choose to either go online or do a local meetup on that day, or do both. So look online on our website, and I hope we're gonna take a small break because it's holiday season, as I've been told. I'll stay here and hopefully see you back end of August somewhere. Bye-bye.